Hello everyone, welcome to Computer Technology Open House Preview for Anthony Truss at Conard High School in West Hartford, Connecticut. Um, as I said, my name is Anthony Truss, nice to meet you. We're going to have a later date that we're going to get together face to face with a Google Meet of some sort that the administration is going to send you a special link. This video is specifically designed to kind of give you a course preview where I will not have time to explain this during the meet that we get together. It's 3 minutes long, and obviously in 3 minutes it's not enough time. So this is designed to kind of give you a course preview before you meet me. And then if you have any questions or comments, obviously, and they're short, you can of course address them during the meet when we meet together. Or you can send me an email privately and we can kind of work on whatever it is that you have a question about with more time. So I focus on the Google Classroom in terms of kind of keeping my course organized, along with obviously every teacher in this district. So this is just an example of our Google Classroom that you have here. I encourage students to focus specifically on the Classwork tab. As you can see here, I have my weeks organized as the topic itself rather than the topics, because we might jump around on different topics at different times. It gets really confusing if it's topically organized. I find that students appreciate the groups of assignments by block of week. So if a student misses some time, they just have to remember what week it was that they were missing based on the date range and then focus on the blocks that are within. So the first week was a pretest and a lot of discussions and team building. The second week we focused on the semiconductor shortage and what it is. And then we did a PC hardware identification lab after a variety of lessons. Week 3, we actually did some hardware removal where students are taking apart a desktop PC. Everyone has the same PC, so everyone, including myself, demonstrates and has consistent hardware that everyone is aligned to, which is helpful. If you had a variety of computers, they're all their own animal. It's nice to have a consistent build. So we pulled out the processor and the cooler that was on top of the processor first, and then students are expected to write up a lab report. What was the process? What were the tools used? What was the intended purpose of the lab? What was learned? What was surprising? And is there photographic evidence of doing that? So this is an example of one of the assignments that you can kind of see that was turned in, where we have a description, the tools, the process that they took to kind of get the project done, and a conclusion about specifically what was hard, what was easy, what was surprising. And the student was surprised that it wasn't as complicated as they thought. It was surprisingly easy. It was a challenge to disconnect the cooler wire that actually turns on the fan. And they had to use a specialized tool. Here's an example of the processor that's been removed out of the LGA socket, as well as the thermal paste on the cooler itself. So students will have to excuse me, demonstrate that they were able to do the activity. While this stuff is going on, I facilitate the lab and make sure that it's going smoothly and take care of any problems that come up. I typically will demonstrate the lab itself before students do it, as well as we'll watch some instructional information that talks about it as well. So we do focus on computer hardware, as you can see here. The various different components, the cooling fan, the CPU, the data storage, the different methods of data storage nowadays. What type of memory do computers use? Why are there different kinds of memory? What are the different speeds? Why is that important? Graphics processing units, graphics cards, and so forth, and the different prices that are there, what they're used for. Of course, students build their computers from the ground up. They're tearing them down first, and then they put them back together. They are functional. They learn how to install operating systems, work with a graphic user interface such as Windows, as well as work with a text-based operating system such as DOS, Disk Operating System, DOS, and so forth. We learn about how these things are manufactured, how they work by themselves, individual component-wise. How is a processor made? How does the processor semiconduct when it needs to? How do the logic gates work? How are the transistors that are inside there made? What are logic gates, and so forth? So lots of questions that we discover the answers to throughout the year. We get into some microcontrollers, such as an Arduino board, where we focus on the Arduino language, which is a version of C++. So C++ is very useful in engineering. as well as microcontrollers and controlling systems. And that's one of the kind of applications of whether it's electrical engineering or mechanical engineering. The point is you can solve problems using this, and regardless of what direction you're going to be going, if it's within the STEM field, you'll somehow end up interacting with these, whether it's coding or physically hooking up electrical circuits, depending on what branch you decide to take. So I expose those types of concepts to students so that they kind of expect these things to see in the field. We also get into microprocessors. So we have a microcontroller, such as an Arduino, and we have a microprocessor, such as a Raspberry Pi. It runs an operating system. It needs an operating system to execute its programs and instructions, unlike unlike an Arduino board that you can see here. We'll typically install like a Linux build on something like a Raspberry because it's free, it's easy to install, and they have built operating systems in Linux specifically for this. So it lets students see different operating systems as well. There's a robotics unit where we do a little bit of robotics. There even is a drone unit where we do some programmable drone work at the end of the year. So we have robots, drones, Raspberry Pis, Arduino boards, electronic projects themselves, building PCs, and a lot of really interesting current events and topics relating to how computing and how computers impact our lives daily, for the good and the bad. And ultimately, it's a pretty fun year. It's lots of topics. That's why it's a full year course. And it's designed to kind of show students what's available out there for careers and give them some confidence in terms of building PCs. They should be able to build a PC by the end of the year, control networks, build network cables, and possibly even take the A+ certification test to get their first initial professional certification if they so choose. And if you're ever interested in A+ certification and would like to know more information about that, send me a private email and we can discuss the options that are available. If you have any other questions, obviously let me know through email. Otherwise, I will see you at open house when we meet. Although it will be short and brief, I look forward to it. So have a wonderful day.